So we start with the first logical connective, the negation. So my advice is that please take the definition of each logical connective seriously and the way we note it, way we write it. Because later on we'll now be combining all those different logical connectives, and it's just good that you need to be keen from the start. Usually the exercise is very easy, but if you don't take it seriously from the start, it can give you some trouble in future, which I don't expect you to have. So the first one, negation. So this will be the structure of our discussion in these 5 logical connectives. The first step will be to define what the logical connective is. We give the notation, and then we give examples on how to interpret the connective, and then you do the truth table. That will be 3 things: definition, examples, and then truth table. So the definition of negation, we require a statement P. So let definition P be a statement let P be a statement. The negation of P is the statement not P. That's simple as that. That's how we define the negation of P, usually denoted by so we write this, or we write this, or we write a bar on top of P. So that is how we define negation of a statement P. So then after definition and giving the notation of the logical connective, then we give examples. So for example, find the negations of the following. So the first statement, it is raining. So when you say the statement is it is raining, then its negation will be if you are denying that the statement is not correct or it's not true. Then we'll say it is raining, negation will be unmute your mic. When you deny statement A, then you correct. So the negation of this statement will be it is not raining. Good. Then example 2. If I say I have a statement B, today is Monday, then the negation will be correct. Today is not Monday. Then number 3, if I have the statement, all dogs are black, then the negation will be correct. All dogs are not black. And then you take the same structure to do negations of any other statement given to you. Just simply, a negation is a denial statement. So you are denying or you are giving the opposite of the statement given. So maybe let me number 4. If I say I have a statement D, Mount Kenya is in Uganda, then negation will be negation of this statement will be correct. Mount Kenya is not in Uganda. Mount Kenya is not in Uganda. Good. So just note, sometimes the negation of a statement P is defined as it is not the case that P. So sometimes you can define a negation of a statement P as the statement, it is not the case that P. So for example, when from this first statement, we say that A is a statement, it is raining. So if you don't want to say the negation is it's not raining, you can as well say the negation of statement A is a statement, it is not the case that it is raining. It is not the case that it is raining. And then the statement B was, today is Monday. So if I want to use the second definition or another way of defining a negation, I'll say it is not the case that today is Monday. Then in that structure, what will be the negation of statement C? Correct. It is not the case that all dogs are black. And then if you had to use that same definition, the negation of D will be? Correct. It is not the case that Mount Kenya is in Uganda. Please know that don't confuse the two ways of defining it. If you are starting with the stem, it is not the case that, then the statement P is written the way it is. You don't do anything, you don't interfere with any word on the statement P, because already the negation has already been taken care of in the stem. When you say it is not the case that, it has already been taken care of. So it will be wrong for you to say that the negation of statement A is, it is not the case that it is not raining. That one will not be correct. because we'll actually be doing double negations on the same thing. So if you decide to use this as your definition of negation, then remember that the statement you have, it will not change anything. When your stem it is not the case that. Good. Now let's say when we say A is the statement it is raining, I want you to observe where you are. Is the truth value of this statement A true or false? Where you are, is it raining now? Kiprop, where you are, is it raining? So therefore, according to you, where you are, the truth value of this statement A will be false. So still, where it is raining is false. So when you say it is not raining, it becomes true false for the same location. When you say it is not raining, will it be now be true or false? Now becomes true, correct. Then, okay, this one is common to all of us. When you say today is Monday, with respect to today, is it true or false? True. So therefore, the truth value of this one is T. Now, today is not Monday, will be false. Then, all dogs are black. Is it true or false statement? It's false. And then when you say all dogs are not black, true. Then Mount Kenya is in Uganda, true or false? False. Now, when you say Mount Kenya is not in Uganda, true. So then now, from these 4 examples, what can you say in terms of the truth value of a statement and its negation? So if the truth value of a statement is true, then what do you expect to be the truth value of its negation? If the truth value of a statement is true, then the truth value of its negation is false. And when the truth value of a statement is false, the truth value of its negation is true. Correct. So therefore now, truth table we'll have this, we'll have P, and we'll have the column for not P. And because we are using the same letter, P, then the number of rows will just be 2. So a statement can either be true or a statement can be false. So when statement P is true, its negation will be false. And when the statement P is false, its negation will be true. So that is the end of that first logical connection. So that's how we deal with negation. So we started by defining what a negation is. We gave examples, and then we have drawn the truth table. We go to the second logical connective, what we call the conjunction. So conjunction, this is the sign we use, inverted V. So to define a conjunction, you need 2 statements. So we'll say, let P and Q be 2 statements. So we're defining a conjunction. So we start by having 2 statements, P and Q. The conjunction of P and Q is a statement P and Q. Usually denoted by this is the definition of a conjunction statement. So you require two statements, say P and Q. Then the conjunction of P and Q is simply the statement P and Q. It's like you are simply connecting two simple statements using the word and. So the word and is a key word in the definition of a conjunction. If you remember what you are doing on sets, we said the word intersection, the key word is and. Similarly here, the term conjunction, the key word is and. The key connecting word is and. So for example, consider the following. So let's have A. Let's have the statement A. B, today is Monday. Statement B with the statement, it is raining. Let C be the statement, 2 plus 3 is 5. Let D be the statement, sugar causes tooth decay. Let E be the statement, tomorrow is my birthday. So let's have this as our 5 atomic statements. Then the conjunction of A and B. From the definition, who can tell us the meaning of this statement? Conjunction of A and B will be the statement. Correct. And we agree that we don't complicate the obvious. So that's the correct answer from the definition. Because we simply say that if we have two statements, P and Q, then the conjunction of P and Q is simply the statement P and Q. So you write the first statement P, delete its full, replaced by the word and then join the second statement. So the answer here, as it has been said, will be today is Monday. Today is Monday. And it is raining. I remember I told you ensure that you do proper punctuation. Where there's a full stop, put full stop, comma, put comma appropriately. Where there's a small letter, let it be small letter, let it be capital. And that would be the correct solution for that. Then, what would be the meaning of this statement? The conjunction of C and D. Please ensure that you answer at least one question before we end this class. It will be bad manners for you to keep quiet throughout the 3 hours. This will mean Correct. 2 plus 3 equals to 5. And sugar causes to decay. Good. And then what would be the meaning of this statement? Perfect. Sugar causes to decay. It's my birthday. So from those 3 examples, I hope it's not very difficult for you to interpret the conjunction of 2 statements, 2 simple statements. If you are given, you should be able to join them. Okay, is that correct? Yeah. So then now the next one is truth table. But then before we draw the truth table, I want us to, we'll make use of this analogy. So truth table. For us to understand how to draw a truth table for a conjunction, we need to make reason of this analogy or this statement. So probably before you admitted to this program, these were the university requirements before you applied and you admitted to this course. So the requirement was applicants for this course should have a mean grade of at least C minus in KCSE and a C minus. Okay, it may not have been exactly this one, but then let's assume this is the condition that applicants for this course should have a mean grade of at least C minus in KCSE and a C minus in mathematics. All of us should understand that when you say, when the description of a course is a C minus in mathematics, then we mean anyone with a C minus and above will still be admitted to that program. So it means C minus. So there are 2 things here. There's what to do with mean grade. There's mean grade, and then there's the score in mathematics. So mean grade, with this respect, thing to do with mean grade, we'll call it statement P. And thing to do with score in mathematics, we'll call it Q. And when the student has at least a mean grade of C minus, then P will be true. And when a student doesn't have at least a mean grade of C minus in KCSE, then the truth value will be F. Then for Q, when a student has a C minus in math, will mean the truth value is T. And when the student has less than C minus in math, then we will interpret it as having the truth value of F. So then now we draw this table. We'll have P, we have Q, and then we have the statement P and Q. But then, how many rows do we expect to have in this table? From our previous discussion, how many rows are we expected to have? If I have two statements, then I'm supposed to have how many rows? 4, 2 power 2, correct. So I'll have 1, 2, 3, 4. So true, true, false, false, true, false, true, false. So then now the way we are going to fill the spaces in the column for conjunction of P and Q, we will put T if the student qualifies, and we'll put F if the student does not qualify for the course, according to the instruction given. So the first line means the student or the applicant has a mini grade of C minus in KCSE, and the student also has a C minus in math. So the question is, according to this course application requirement, will that such a student qualify for that course? Yes or no? Yeah, they qualify. So then we put here T. Then what would be the meaning of the second line for those who are following? Correct. The second line means the student has a mini grade of C minus in KCSE and does not have a C minus in math. So according to this course application, that the student should have a mini grade of C plus, a C minus in KCSE and a C minus in math. Do they qualify for the course? They won't, they don't qualify. So therefore we put here F. So put F here. Then the third line with respect to this analogy will mean correct. This one means the student did not make it, did not get a mini grade of C minus in KCSE, but then the student has a C minus in math. Do they qualify? They still don't qualify according to the instruction given for the application. Yeah. So put here an F. Then what are the last line mean? Correct. So do the such a student qualify for this course? No. So therefore you put here an F. Correct. So put here an F. So did a complete truth table. So from this truth table, what summary can you make out of it? Like when do you expect to get a true value for conjunction, or when do you expect to get a false value for conjunction? If you have two statements, these results are written in blue. What summary can you make to tell someone that whenever you are dealing with a conjunction, then this will always be the outcome if the false values of the atomic statements are this and this? What can you say about the final results and the initial truth values of the statements? Like if I ask you, when are you sure to get a true value for conjunction? What guarantees you to get a T value? Yeah, when both statements are true. That's only when you are guaranteed to get a true, okay? Otherwise, when all of them are not true, then you'll get an F. So that's the take home from this table, that are not a conjunction of two statements is only true when both statements are true. Otherwise, what do you get? Otherwise, otherwise, complete the statement. False, correct. Otherwise, it will be false. So that's the main take home. So that when someone asks you to draw a truth table for a conjunction, you simply identify cases whereby all the truth values are true, then you fix T. Then other things, which is a mixture of T and F or both F, you put F. Then that will be a complete table. Then number 3, disjunction. So disjunction, we use this notation, which looks like a V, capital V. Then first, as usual, is to define the statement and then give examples, and then we'll draw the truth table. So let P and Q be two statements. Otherwise, so let P and Q be two statements. The disjunction of P and Q, denoted by is the statement P or Q. So the disjunction of two statements P and Q is the statement P or Q. So let's give examples to see how we can construct this. So if I have A, the statement, it is raining. B, the statement, today is Monday. C, the statement, 4 plus 6 is 7. D, the statement, Eric is right-handed. Then who can tell us the meaning of this statement? What will be the meaning of that statement? Correct. It is raining. Or today is Monday. Please remember, when we are constructing compound statements, sometimes things we form may not make any sense in English in normal world, but what there is the logical connection. So sometimes the compound statement we are forming may not be sensible under normal circumstances, but what we respect is the logical connection we are discussing. Then what would be the meaning of this statement? Correct. 4 plus 6 is equals to 7, or Eric is right-handed. You see, Eric being right-handed and 4 plus 6 equals to 7. There's no relationship. It may not be nice to those who are studying language, but for us, it is correct with respect to what logical connective we are discussing. And then, what would be the meaning of the statement? This? This will mean? Correct. Today is Monday, or Eric is right-handed. So that's usually what we do. So what we do to form a disjunction if we are given two atomic statements. So then now with the three example, then it should be good to do as many other examples as you like. So the next is now to draw a truth table. And then also for us to understand how to draw the truth table, we'll also require an analogy to help us interpret the values. And the analogy here is job advert analogy. So consider this. Applicants for this job should have a first-class honors or a 3-year work experience. Applicants for this job should have a first-class honors or a 3-year work experience. Then let me draw the truth table. Then will explain what each of the. So this will be Q. This is P. But how many rows are we expected to have in this? 4 still, because there are only 2 statements. So 1, 2, 3, 4. So true, true, false, false. And then we have true, false, true, false. Then, so here there are 2 things here. So one is the acquisition of first-class honors. So first-class honors will represent P. And then work experience will represent statement Q. So this is how we are going to interpret this analogy. That's anything to do with the score in the degree, we call it P. And anything to do with work experience, we call it statement Q. Then T under column P will mean that the applicant has a first class honors. F under P will mean the applicant does not have a first class honors. Then T under Q will mean the applicant has a 3-year work experience. And F under Q will mean the applicant does not have a 3-year work experience. Then now our interest here, this last column, we will put T if the applicant qualifies for the job. And we put F if the applicant does not qualify. So that's how we are going to interpret this. So I want you to help me interpret the first line. With respect to this analogy, what does it mean?
The first line means that the applicant.
Correct. Yeah, that would mean that the applicant has a first class and also has a 3-year work experience. So the question you ask yourself, does this applicant qualifies for the job? Yes. So if they qualify, we put T. So put T here. Then what does the second line mean? But fails to have a 3-year work experience. Yeah. Good. So then with the interpretation of this job advert, does this applicant qualify for this job? They still qualify, okay? Yeah. So these candidates still qualify for the job. So put T here. Then line 3. Correct. The applicant is failing to have a first class honors, but has a 3-year experience. Do they qualify? They still qualify. So put T. Then the last line. That this candidate qualify. So the candidate does not qualify. So put an F. So here we put F. Good. So that's the complete truth table. So what summary can you make from this table to explain to someone else who is not in this class how to construct a disjunction truth table? What summary can you make if you check or if you compare the final truth values of the disjunction and the original truth values? Yes. Yeah. So, but when both of them are false? Yeah. So then now we can make this summary. So NB. And please, these things we are saying NB after doing the truth table are the one that you need to take care of. The things we are writing as analogy, they're just to help us now to see how we are forming these answers. So the last statement we are adding as an NB is really what you have to understand when you'll be now reading and discussing about these logical connectives. So we say disjunction of two statements is only false when both statements are false Otherwise, what do you say? Yes, otherwise true. Just ensure that. Otherwise true, correct. Yeah, so that's the main take home. That when you are constructing a disjunction truth table, then just check a line that has everything as false, you fix as false. But any line that you see at least a T, then the final answer must also be a T. So that's the verdict you're making on that. So it is only false when both statements are false. But if all of them are true or one of them is true, then the statement is true. Then before we wrap up on this disjunction, I want you to help me interpret these two statements. So consider the following. One, tomorrow I will go to school or to see a dentist. Tomorrow I will go to school or to see a dentist at Nairobi Hospital. And then number two, tomorrow I will go to school or attend my grandfather's funeral. And then number three, applicants for this job should have a first-class honors or a 3-year work experience. These are enough. So I want you to tell me any observation you can make in these three statements. Anything that you can observe from these three statements. What observation can you make from these three statements? Yes. So okay, before start being start reasoning now, what can you just observe from all the three statements? Okay, before you become start now analyzing what each of them mean. I just want from 1 to 3. What is common? Uh-uh. Assuming that you have not heard of the countries that all of them are using the word or, no? so that all these three statements, there's a word or being used to connect there's use of the word or. Now let's say whether now the interpretation of each of the statement to say if it is the same or it is different in all these three statements. Like the first statement, when you say tomorrow I will go to school or to see. Now when tomorrow comes and this person goes to school and fails to see a dentist, is it in agreement with what he said initially? And then when tomorrow comes and this person doesn't go to school and sees a dentist, is it still in agreement with what they initially said? Then when tomorrow comes, is it possible that this person will go to school and see a dentist? Okay. It's like now it's not, the person is not allowed to do both. And then now let's go to case, to problem, to second. When tomorrow comes, and this person goes to school and fails to attend the funeral, is it still okay? Then when tomorrow comes and this person fails to go to school but attends his grandfather's funeral, is it still okay? Okay. When tomorrow comes, is it possible for this person to go to school and at the same time attend grandfather's funeral? From the framing of the statement, is it possible for this person to be at school and also attend the funeral? So it's like this person is not allowed to do both activities the same day when tomorrow comes. Good. Now for number 3, this person who has a first class honors, a person who has a first class honors and doesn't have a 3-hour experience, do they qualify for the job? They qualify. And then if the person fails to have a first class honors but have a 3-hour experience, do they qualify? Then if the person has a first class honors and at the same time has a 3-hour experience, do they qualify? They still qualify. So then you see the way the word or is used in 3 is different from the word or is used in 1 and 2. They don't mean the same. 1 and 2 is like does not allow 2 activities to happen simultaneously. But in 3, 2 activities can happen simultaneously and there will be no problem. So which means then the term or has 2 dimensions. One dimension is the inclusive aspect, which takes care of everything. But the other aspect is exclusive sense, which does not allow all the activities happening simultaneously. So then that one results into 2 types of disjunctions. There's what we call inclusive disjunction, and there's what we call exclusive disjunction. So we'll define each of them. So we can see that the use of the word or in 1, 2, and 3 is not the same, i.e., in 1 and 2, 2 activities cannot happen simultaneously, while in 3, both are allowed. Therefore, OR has 2 dimensions. There's what we call inclusive, and there's what we call exclusive sense. And this one results into us having disjunction we have what we call inclusive disjunction, which we just use this same notation we have already given for disjunction by default. And then the exclusive disjunction. We use this notation. So when someone says disjunction and they keep quiet, by default, we mean inclusive disjunction. But when we want to bring the exclusive nature, we use this exclusive disjunction. And so the formal definition of exclusive disjunction so we use this notation, or we use this notation, or we use this notation. So we say let P and Q be 2 statements. The exclusive disjunction of P and Q denoted by or is a statement P or Q but not both. So the exclusive disjunction of P and Q is the statement P or Q but not both. So for example, if I have A, in the statement, it is raining, and I have statement B, today is Monday, then if I want to bring the exclusive nature of the disjunction, if I write this statement, then this will mean it is raining or today is Monday, but not both. So there will be rare cases like the examples we have seen, 1 and 2, whereby when someone reads, it will come out naturally that does not allow two activities to happen simultaneously. So for us to be sure that what we are referring to is an exclusive sense of the disjunction, we will be adding the term, but not both, just to make it very clear. So it is not raining or today is Monday, but not both. So we mean any of the two activities or any of the two statements, but not all of them at the same time. Then what will be the meaning of this statement? What is the meaning of that statement? Sure. Do you agree? Yeah, so you must always add the term, but not both. You know, when like today is Monday and it's raining, there's no, it's not as obvious like the first two statements we saw here about tomorrow going to school and attending funeral or going to school and seeing a dentist. So just to make it come out clearly, you add the word but not both to make the distinction of the usual disjunction and the exclusive disjunction. So yeah. Yeah, so you'd say today is Monday, or it is raining, but not both. So you must always add that one, but not both, just to make it very clear that you are only interested in one of the two activities. So then the truth table for this, exclusive disjunction is not very hard to interpret, even you don't require an analogy. Because if you have this our P, and this is our Q, P, Q. So 1, 2, 3, 4. So true, true, false, false, true, false, true, false. So when do you expect to have a true value for the exclusive disjunction? What is expected? Like when one statement is true, the other one is true. What the verdict about the exclusive aspect of the connective? Or maybe let me ask, when do you expect to be the correct case scenario? Like, okay, maybe let just go to this first example where we're saying, tomorrow I will go to school or I'll attend my grandfather's funeral. When one statement is true and the other one is false. That's one when the true case scenario, correct? So this way will have true, this will have true. Otherwise, these other things will not be correct. So for the exclusive disjunction to be true, then you expect the two atomic statements to have opposite truth values. So when one is true, the other one is false, or the other one is false and the other one is true, is when you expect to have a true value. Otherwise, you get a false. So we can make that NB here. The exclusive disjunction is only true when the two atomic statements have opposite truth values. Otherwise, it is false. So I give an 8 minutes break, and then I come to finish the last connector.